is problem 90 of Neetcode 150, number of connected components in an undirected graph. So we're going to receive a graph with n nodes, and we're also going to receive edge, which is a list of lists, and in each list within the list edge, we have a tuple 0 and 1, or 0 and 2, and they're going to represent basically an edge. So it's going to tell us that two nodes are connected. We know that the nodes are numbered from 0 to n minus 1. So this is cool because we can basically use their value as the index as they start from 0. And we have to return the total number of connected components in the graph. So what does it mean by having a connected component? Let's see it now. So let's say that we have a 1 connected to a 2, connected to a 3. So this is one component. And what if we have like 4 connected to 0? Well, this is another component. So in our code, we have a first component here, and we have a second component here. So that's basically what it means. So the strategy that we are going to use is, first we're going to have to go through every single node, and for every node we're going to have to go see the other nodes it is attached to, and we have to keep track of the nodes that we've seen. And we're going to use a technique that is somehow similar to the problem number of Iceland, where once we saw an Iceland, we find a way to mark it as seen. So we are going to find a way to mark all the nodes that we visited as seen. So let's say we start at 1. We're going to go see its neighbor, so it's 2. We'll go see the neighbor of 2, which is 3. And we will mark 1, 2, and 3 as done. And after this round, we are going to keep track of, let's say, a component variable that is initially 0. So we're going to increment this variable by 1. And after this, we're going to go for every single node, and we'll first check if the node, is it seen? And if a node has not been seen, it means that its component hasn't been visited yet. So we're going to keep going. Let's say we go see 2, but 2 has been marked as seen, so we're just going to pass. Or we're going to go see 3. 3 has been marked as seen, so we're just going to pass. Now we're going to go see 4, and 4 has not been seen, so we're going to go see its neighbor, and we're going to mark all its neighbors and the neighbor of its neighbor as seen. So this is going to involve a depth first search algorithm because we want to go see all the neighbors and the neighbors for neighbors. So let's go ahead and start coding this. So the first thing that I want to do is that I want to keep track of the neighbors of every single node. And since we know that the nodes are numbered from 0 to n minus 1, I will use this to basically make a structure that is simpler than a hash map. I will simply create name, which stands for neighbor, and I will create a list for basically for a list that is the length of the number of nodes that we are given. So for pretty much everything in the range of n, right? So if we have 6 nodes, we're going to have 6 empty lists. And we know that our nodes are going to be level from 0 to n minus 1. So they will look like 0, 1, 2, 3, and 5. So we can use their index to, their value to store their neighbor at the index that their value is. And now I want to create something that I will call scene. And this scene is going to hold basically n times yes or no. So I will first create basically n times n, which stands for no because we haven't seen it. And n is basically the input we are given that represents the number of nodes that we have. So we know that for each node, at their index, there will be n at first, meaning that we haven't seen it. And now basically, after we created the blank neighbor pseudo hash map, we actually have to fill it. So what we're going to say is that we're going to go for every single values inside edge. So I will say for A and B in edges. And inside neighbor, I will first insert a first key, which is A. And at this A key, I want the value to be equal to B, because B is for sure one of the neighbor of A. And I'm going to do the same thing for B. So at the key of B, I'm going to append A. All right, so now we have our pseudo hash map. And at each index, we know that the index itself is going to represent the node. And for that particular node, we're going to store its neighbor. So now we have pretty much all our variables completed. We can create the depth first search function, in which we're going to pass a node. So what we're going to do is that we're going to go for every single neighbor of each node, and we will do so by saying for I will say just name, because I don't want to use n directly, as it's going to be confused with the input we're given. So for name in the hash map of the neighbors, and we want to use the node that we have passed as the parameter as the index. So for all the neighbor that we're going to find, what we're going to be willing to do is you want to check if that neighbor has already been visited yet. So we're going to say if seen at name. So if this if this is equal to no, meaning we haven't seen it yet, we are going to mark it as seen, and we're going to go call a depth first search function for all the neighbor of that neighbor. So I will say seen at the index of the neighbor, and I will set this equal to a y for yes, and I will call the first search function on this neighbor. And that's pretty much all we want to do inside the depth first search function. After this, we are basically just going to go over every single node, and we're going to call the depth first search function on it if it hasn't been seen yet. We also want to keep track of how many components we have. So I will create components, which is initially 0. And now I will say for all the nodes inside the range of the number of nodes are given, if we can see that this node hasn't been seen yet, so we'll do so by checking the in seen at the index node. If this is equal to no, we know that there's another component that lies right here, whether it's the node itself or that node connected to other nodes. We know that there's another component to see, so we can first set that scene as yes, because we saw it. So this, so we're going to do that, and then we're going to call a depth first search function on this node, and finally we're going to increment comp by 1 because we found another component. So by doing so, we're going to go see every single node. So if we have only, well, let's actually walk through this example. So if we start with, well, we're going to start with 0, right? So we're going to go see 0, and we're going to mark it as seen. We're going to go see for its neighbor. We're going to mark it as seen. And our depth first search function is going to end after this. So now we're going to keep our loop, and our next number is going to be 1. So 1 is going to be marked as seen. It's going to go see its neighbor 2, which is going to be marked as seen. And it's going to go see its neighbor 3, which is going to be marked as seen. And in the meanwhile, we'll have incremented comp twice. So comp will be equal to 2. And this is what we want to return. All right. So let's test this out. And we have an error. Indentation level. So Okay, there we go. So I hope you learned from this video, and I hope to see you in the next one.